Hello everyone. Today we're going to discuss about our article, which is determination of alcoholic compounds of resinous compounds by using gas chromatography and mass spectroscopy, GCMS. So now we're going to move to our group members.
Let me introduce you our group members. First, Amna Safia binti Zulkarnain. Second, Nur Nisa Azrin binti Ghazali. Third, Muhammad Haikal bin Mahmud. And the last one is Muhammad Zul Aiman bin Zulkifli.
Now we're moving to the abstract. In this study, the alcoholic compounds of resinous compounds have been evaluated. The chemical composition of the leaf ethanol extract of our resinous compounds were investigated using gas chromatography, mass spectroscopy, GCMS analysis of resinous compounds alkaloid leaf ethanol extract revealed the existence of the N-hexadecanoic acid, octadecanoic acid, 1-hexadecanol, 2-methyl, keep 3-in-1, 10-decarboxylic acid, 2,4-S, 7-trihydroxy, 1-methyl, 8-methylene, 1,4-A-lactone, 10-methyl, alvaline, ethyl ester, hexadecamethyl, tetradecamethyl, octadecamethyl, butane dioic acid, hydroxyl, diethyl ester, triethyl citrate, diethyl phthalate, and 3-octadecene. For the introduction, resinous communis is commonly known as the castor oil plant, Palma icaristi, or the wonder tree. It belongs to the spurge family, Euphorbiaceae. It likely originates from Africa and has historical use dating back to ancient Egypt, Greece, and Rome. The plant contains highly toxic compounds, including ricin, that is a type 2 ribosome inactivating protein, and hemagglutinin, RCA120. It also contains a low molecular weight piperidine alkaloid called ricinin with molecular weight is 164.2 gram per mole, which acts as a strong insecticide and makes up about 0.2% of castor seeds. Other phytochemicals is fatty acid, flavonoids and saponins are present in the plant, contributing to defense mechanism against bacteria, virus, fungi and invertebrates. Resinous communis has a rich history in traditional medicine, where its seeds and oil were primarily used as folk remedies for treating warts, corns, moles, and internal indurations. Most notably, castor oil is celebrated as a powerful laxative and a traditional aid for inducing labor, while its derivative, resinolic acid, has been utilized in contraceptive jellies. Additionally, the leaves serve as versatile topical treatments, frequently applied as poultices for boils, headaches, dermatitis, and eye ailments.
Okay, we had three main objectives. The first objective of the study was to extract alcoholic compounds from resinous communis leaf, and the extraction process was carried out to obtain the chemical constituent present in the plant for further analysis. Okay, then the second objective was to identify the compounds present in the leaf extract using gas chromatography, or we call GCMS. This technique allows the separation, detection, and identification of different chemical compounds in the sample. Okay, lastly, the final objective was to determine the phytochemical profile of the leaf extract by identifying the compounds detected through GCMC analysis. This information helped researchers understand the chemical composition and potential medicinal importance of the plant.
This is the GCMS profile that shows the chemical composition of resinous communis leaf extract. Each peak represents a different compound separated at different retention time. The height of peak indicates the relative abundance of each compound. A higher peak means that compound is present in the greater amount. Overall, the graph shows the extract contains multiple bioactive compounds with varying concentration. The GCMS analysis showed that 9 phytochemical compounds were present in the resinous communis leaf extract. Each compound was detected at specific registration time as shown in the table 1. Among the identified compounds were alvaline ethyl ester, triethyl citrate, diethyl phthalate, and hexadecanoic acid and octadecanoic acid. The presence of this compound indicates that resinous communes contain a various bioactive substances which may contribute to its medical properties. Therefore, the GCMS analysis successfully provides the phytochemical profile of the leaf extract. I will explain the part of discussion. The discussion will explain the result of analysis of the extraction leaf. Various phytochemical compounds were identified in the resinous communis leaf extraction. The GCMS analysis successfully identified 9 phytochemical compounds in the leaf extract. This indicates that resinous communis contain a diverse range of bioactive substances that may contribute to its biological and medical properties. Next, fatty acids were among the major compounds detected. Compounds such as N-hexadecanoic acid and octadecanoic acid were identified in the extract. These fatty acids are commonly reported in medical plants and are associated with the several biological activities. Next, the identified compound may contribute to antimicrobial activity. According to the study, some of the detected compounds possesses antimicrobial properties. Their presence suggests that resinous communes may help inhibit the growth of certain microorganisms, including bacteria and fungi. Next, the extract demonstrates potential therapeutic value. Beside, beside antimicrobial activity, several compounds identified in the extract are known of their antioxidant and therapeutic effects. This property may support the use of resinous communes in the development of natural medical products. Next, the findings support of traditional use of resinous communes as medical pen. The presence of bioactive compounds provides scientific evidence for the traditional application of resinous communes in treating various health conditions. This highlights the importance of medical plants as potential source of the therapeutic agents. Lastly, further studies are necessary to evaluate safety of effectiveness. Although the plant contains beneficial compound, resinous communis is also known to contain toxins such as resin. Therefore, further research is needed to determine the safety, efficacy, and pharmaceutical potential of identified compound. Yes.
Alright, now let's look at the method. First, we go to plant material prep and hot extraction. So, look at the standardized processing workflow. First, drying protocol. Starting with leaf of resinous communis were dried gently at room temperature for 10 days to achieve complete moisture elimination. Second is homogenization. The dried plant material was pulverized using a clean pestle and mortar to ensure zero contamination. Next, look at the sieve reduction. The powder size was standardized and reduced using a high-density wire sieve. And then, storage parameters. It is stored inside hermetically sealed airtight containers to eliminate humidity degradation at stable room temperature. And the last one of the standardized processing workflow is primary acid ethanol boil. 2 grams of fine powder was boiled in a dedicated water bath containing 20 ml of 5% sulfuric acid and 50% ethanol. Alright, then we're conducting alkaloid fractioning and separation. The first one is filtration, where the boiled plant solvent mixture is cooled down and filtered carefully. One portion is reserved for verification, and the remainder is isolated for partitioning. Second is alkalinization. The isolated filtrate is transferred to a separating funnel where concentrated ammonia solution is added dropwise to make the medium distinctly alkaline. Next is chloroform partition. An equal volume of chloroform is introduced, shaken gently, allowing clean phase separation. The dense lower chloroform layer is isolated and decanted. The last one is acid extraction. The accumulated chloroform layer is re-extracted using two distinct 5 ml fractions of dilute sulfuric acid. And we're moving to qualitative alkali identification test. First is Mayer's test. Reagent and formula addition is 1 ml of filtered acidic extract is treated dropwise with 1 ml of freshly prepared Mayer's reagent. The positive result indicator is formation of a greenish or cream precipitate. For the Regendorf test, reagent, formula and addition is 1 ml of the test filtrate is treated dropwise with 1 ml of formulated Regendorf reagent. The positive result indicator is formation of prominent reddish-brown precipitate. And the last one is Warner's test, where the reagent, formula and addition is 1 ml of test filtrate is combined dropwise with 1 ml of iodine-based Warner's reagent. The positive result indicator is formation of a distinct reddish-brown precipitate. Then we continue with the GCMS instrumentation.
In conclusion, resonance combines certain chemical constituents that may be useful for various herbal formulation and medicinal application. They conclude that resonance communis is an important medicinal plant that requires further exploration to utilize its medicinal properties. In addition, further studies are needed to identify and understand the active compound present in this plant to ensure that effectiveness and safety in different medicinal use. The potential of resonance communis show that it can be further developed as valuable source of natural-based treatment in the future.